Is going to tell us what is the world's most misunderstood programming language. Now, Daniel is now working as a full-stack developer. However, he is more well-known as a founder and also as a manager of Meteor Spark, a Hong Kong-based meteor consultancy. Please welcome Daniel.
Thank you for the presentation, and you pronounced the last name pretty well. It's the first time.
I try my best.
Yeah. So, as a JavaScript developer, I happened to meet many other JavaScript developers, and I found out that many people don't really take the time to learn properly the language. They use it daily, or sometimes occasionally. You know, JavaScript is almost everywhere today, both in the backend and the front end. But people just use it and hope that it will work the way that they wish. Some of the things that I'll show in the talk today are the things that I personally think that those that understand this concept understand pretty well how JavaScript is functioning. Now, for some of you, these things might look obvious. Those of you that will find the things that I'm showing here today to be obvious, I would be very happy to meet you, as I'm currently looking for JavaScript employees. So if you are looking for a job in which you'll do very challenging things in JavaScript and in web development in general, please contact me after this talk. Don't be shy. In this talk, I'll cover three concepts. One is the event loop, another one is closures, and another one is the this variable in JavaScript. All right, so let's begin from example number one. We have here a function that called print correct text. The function set text to print, that's a global variable set here to be correct text, and then logs the variable. I also initiate here a set interval. Interval call a certain callback, in that case this function, every 100 milliseconds. So every 100 milliseconds, set interval will set text to print to this value. Now the question is, when you develop JavaScript programs, how do you protect yourself from occasions where you set a certain variable and you expect it to have a certain value immediately after, and then something like this set interval might come and change the value of the variable? How can you protect from something like that? You know, it can be someone who click on a button that change a variable, whatever. So that's example number one. I'll soon return to it. Example number two is this set timeout. And this set timeout just need to log into the console the word woke up after 1 second. Now, we can't really trust this function in JavaScript. And the reason why we can't trust it to really fire after 1 second is the same reason why what I showed earlier is a bit tricky. So if anyone wants on the first example, if anyone has the courage to say how we protect against a situation where a certain other callback will change a variable while we're running, anyone have an answer? Yeah, it requires the courage. Oh, you have, okay.
Put the variable inside closure. Put the variable inside a closure.
That's potentially could have been a way to solve it. And all right, that's one answer. I'll return to this answer. And
TypeScript, so you can set it with a constant.
That's another answer. But I said it's going to be tricky. Okay, it's going to be tricky. You said that if you set it somewhere as a constant, no set interval will be able to come and change it to you a moment before you print it. Okay. Now, what about the second example? Anyone knows why we can't trust at all this set timeout to fire in 1 second?
Because JavaScript is a single thread, this is not guaranteed to run at except 1 second. There may be something that's running and blocking that thing to run.
That's exactly the answer. And that, in a way, is the reason why this example is very tricky. because JavaScript is single-threaded, while this code is running, even if 100 milliseconds just happen to come between that call and that call, okay, it won't happen, okay? This set interval will never interfere in the middle of the running of this code, okay? So this is why it's a bit tricky. And now, this brings me to the concept of the event loop, okay? And you know what? I want to give a real example here. Many of the things we'll do in this talk, I'll give actual examples for. All right, so in the console, I'm going to call this set timeout after 1 second. Was it 1 second? Yeah, after 1 second, it's called a woke up. But if I'll call just after this set timeout a function such as confirm, okay, it's hard to see it in this way, but you can see that as long as the confirm button is not clicked, even though 1 second passed already, the woke up won't show up. After I'll click on OK, then woke up will show 1 second later. So JavaScript is single-threaded. Only one piece of code runs in any given moment. You don't need to worry about code interfering while a certain block is running. While JS is processing code, events are queued in the events queue. Okay, it's like represented here. Imagine that event, such as, for this example, set timeout is like an event that fires after 1 second. So, but it could have been a click or anything else. So once event is firing, it gets into a queue, not a stack of events, and only once the event loop, that is the process in JavaScript that call the part of the code that needs to be processed, complete, and wait for it to complete, and then look what is the next thing in the event queue that needs to be run. Only once the event loop will get to that event, only then it will run the event handler that it has. So as long as a certain code keeps running, it blocks the event loop. No further events will be handled by the event loop. Once the processing of code is completed, the event loop takes the next event from the queue and calls it its handler. So, by the way, there is a great talk about the event loop in much more details here in this short talk. We can go much deeper into that, which is what the heck is the event loop anyway. And I would suggest reading the MDN page about concurrency model and event loop. Okay? Yeah. All right. So the next concept I want to discuss, you see, I'm just touching here concepts. I'm not really going deeper into any of them. Is the concept of closures. Okay? Now, in this example, I set message, a global variable, to not interesting message. Then I have a function here called print sequence, print_sec, and it defines message to interesting message. Okay? You can see that it has the var word here, and then it runs a for loop in which it 10 times call to this thing, this set timeout. Now let's see what happens if I call this. Okay, you can see that it printed for me 10 times interesting message, and before every time it printed the number 10. But when I wrote this function, I expected it to write the numbers starting from 0 to 9. So 0 dot not interesting message, 1 dot interesting message, and so on. And for some reason, all of them, all the console log that I see, print the 10 and then interesting message. So the first question is, why it didn't print it sequentially? Why it didn't print, why the I, in that sense, have the number 10 when the console log print when the console log logs after 1 second? Okay? If anyone want to answer this one? Yeah?
I think it's because when set timeout, I mean the whole thing runs,
Right.
and the value set to 10, and then it starts printing it out. So I don't understand.
Exactly. That's the reason. The reason why it happens is because once I call print_sec, okay, these for loops run from 0 to 9 to 10, but 10 will never run, from 0 to 9, and all this time it calls this set timeout, okay? But by the time this set timeout will call, I is already 10. It's already went out of the loop, and for that reason, it's we get the 10 dot interesting message. Now, and this is where we get to the interesting part. How can we solve that? Okay, how can we fix this thing? Okay, so those of you who know the answer, which is pretty common, please don't answer yet. If anyone have the courage to give a try when he's not sure, I will be interested. No, okay. So I tell you what is the usual answer that I get. I give this kind of question in job interview. I get something like this. They tell me, okay, just take the part that you do here, okay? Call a function with I as the current I, and let it print. Just take this part out into another function, and this is what we see here. We see that this for loop now calls the late print message with I. So in a way, the late print message now keeps the value of I and calls set timeout. And once this set timeout will run, it will use the I of this language of this function basically, and it will print it correctly. But the thing is that it's still not going to work well because let me call print_sec in that case. Yeah. You see, instead of printing the interesting message, and that's the, it's hard to see here. Okay, instead of printing the interesting message that I wanted it to print, that was inside print_sec, okay, it prints the not interesting message that was defined at the beginning of this call. Okay, so instead of printing this, okay, this message, it prints that message, because this message here now don't refer to the right message. So here the question is, how can we still fix it? And before I answer this question, I'll explain a bit about closure and the way that JavaScript variables work. So variable names in JavaScript refer to their declaration in the closer and closing function, in which they are either defined with the var word or are arguments of the function. Okay? Here there is a definition of closure. It's not so critical for this discussion. And here is an example of what I just said. I have here a function, I have here a piece of code that set A, B, and C to 1, 2, and 3 respectively as global variables. And then you'll see that if I'll console log this, it's quite easy. It will print 0, 0, 1, and then 1, 2, 3. Okay? Now I wrote the function x that does the following. It gets A as parameter, okay? And it logs ABC again. Then it defines a function, that's what happens here, and immediately call it. Okay, in JavaScript we don't really need to have names for functions. You can just call a function. That's what happened here and here. I basically just call the function I declare there. And inside this function I set the variable B with var in front of it, and then I call again ABC. And here, let's run this in the log. Clear console. All right. So if I call this, you can see that 001, that console log, printed 1, 2, 3 as expected. 002, that's after we called x5. Now A was defined as one of the arguments of x. So because of that, when I'll call A inside this function, it will refer not to the global A, but to the A that was defined as the argument. Okay? So this A here refers to this A. Okay? And now, immediately I call the function that I declared inside. Okay, and you can see that what this function printed after it set var b equal 10 is 003, 5, 10, 3. Now, this b here didn't refer to that b, but to the b that was defined with var. Okay, and so on. So in two ways, we define variables and the way in which they need to be referenced, either as arguments of function or with the var word. Now, if, for example, b was defined as var b here, okay, this b, okay, here would still refer to that b over here, because this is the closer b with var that we have. Now, I want to show a feature of Chrome that is quite useful. Let's set a breakpoint here. In the developer toolbars of Chrome, and actually in any other modern browser, you have a way to set a breakpoint and to actually see what we call the closure. That is the context that we derive our variable name from. Okay, so I'll set two breakpoints. One over here, okay, when I just call x, and another one over here when I about to call 003 here, okay? And now let's call x, let's call this function again, okay? So let's call x5 and see what happens. So you can see that in the sources, once we set a breakpoint, under scope, we see the scope of names of the variables we are using, okay? In that case, we have two variables here. One is a, and the other is this. I might talk about this later if we'll still have time. And a is set to 5. Now you can see that in the global namespace, okay, that's the upper and closing encapsulation, if you'd like. This is the where all the global variables are defined. Let's find x over here. Yeah, here it is, not x. I wanted to find a, yeah. Here it is. Okay, so here you see a, and this is where we are in the global namespace. So now let's keep running, and you can see that once 003 is hit, then the scope is we have the local b, okay? A, we're actually taking from the enclosing closure, okay? Here, we get a, and we can see it very clearly. And then, I won't show it again, we have also C from the global namespace. And that's basically the concept of closures and how we use them. Now let's return to the example. Okay, back to the example, the original example. The right way to do what I wanted, to keep the set timeouts in the way that they were defined without losing the context of this message, okay, and still print it in the correct way from 0 to 9, was to basically create another function, okay? That function gets I as parameter. Once this function gets I as parameter, when we invoke it, I here does not refer to the enclosing I, this I, it refers to the I that was provided as parameter, okay? And for that reason, it's going to do it correctly. Now, message does not going to take message from the global namespace. It doesn't going to take this message, but actually the message that was defined here in print_sec at the beginning. And believe me, it works. I won't waste time on showing it. It showed it correctly. This. I'm defining in this example x to be an object that has three parameters. One is a, another is b, another is c, and each one of them is a function. The first one is quite a simple function. It just returns 1. The second one return this dot a, and c is creating a set timeout that calls a function that logs this dot a. Now see what happens. Yeah. There is even a more interesting situation. Let's try. Okay, if I'll set A to be x dot A, x dot B, B equal x dot B. Let's call B. This dot A is not a function, okay? And even though that if I'll call x dot B this way, it will return 1, okay? So this is what I'll try to explain here. What is this, okay, and how it works, okay? All right, let's begin from the simple thing. Who is this? In a simple call, if you will call a function f1 that just return this, okay, what it will return is the global object. In the case of, if you run on a browser, it will be a window. If you run on Node.js, it will be process, okay? But this is what it will return. Basically, this almost have no meaning for us in that situation, okay? But that, by the way, already explains why when I called B just now this way, it tells me that this dot A is not defined because this is window in that situation. Okay, so let me show it again. Yeah. In this case, if I call B this way, this dot A, this will be window. Okay? If I call, and that is the reason that it doesn't work, because window dot A is not defined. By the way, I could have defined it and then it will start working. Let's make it a function. Return 9, okay, and then let's call B this way. You see that it returns 9 because A, when it's set this way, it's set on the window. Now window.A is A, okay, which is the same thing as this one. So this is why it doesn't return the right result in the first example. Let's show it again. This is x.b and this is B. Same function in theory, but return two different things because the this is different. Now let's go to the next example. If we are calling a method, like in this case, okay, this will be the object that is just preceding the period. In that case, if I call console log o.f, the object that I will, this will be O, okay? This will be this O, okay? Now, the last example is if we build a constructor. That's when we use the new argument. By the way, every time you use new, what new is doing is to create a new object and to pass it as this to the function you're calling to. Okay? This is what new is doing in JavaScript. So in this case, we have a constructor C. That constructor set this dot A to be 37 and then return this. Now what's going on here is that O is equal new C, meaning we create here a new object. That object will pass as the word this to C, and this dot A will be 37. Okay, meaning that O dot A will be 37 because this is what this constructor is basically doing for us. Okay. Oops. All right. So these are the three examples of how JavaScript how JavaScript assigns the word this. Now, what do we do with all that? Let's fix the original example, okay? Yeah, I have it. Okay. So, you can see that this time, okay, we need to do it slowly. Okay. So we set again everything the same way, okay? Now, the only difference is, okay, and this has to do with what we talked earlier about closures. The issue that we had in the original example where we called this dot A was that this referring sometimes to one thing, the other time to another thing, and so on. We can't control what this is referring to. But we can control, but we know that when we call this function, we know what this is. I'll show it again here. When I call this function, when I call this function C, I know what this is because here I call x.c. And if you remember, if I call x.c, this will be this x, okay? So I know that x.a should return what I want, but it's going to change because there is a declaration of another function that will change this for us to window, because this is a function that is invoked this way. Now, the way to fix that example is by using closures, as we showed earlier. Because I know what this is when I'm calling C, I can simply say this equals self and keep now the original value of this into a word named self, and then call the set timeout, but this time not use this, but use self, because self will retain its value within this closure, okay, within that containing function, okay. Now, as for, I wanted to show another thing, and this is how we can manipulate this. Say that we want to call a function with a this of our own. We want to control what this is, okay. That's things we can do with two functions in JavaScript. One is call, another one is apply. There is a difference between them. I won't get to that difference, but what I will say right now is that these two functions, when you call them, okay, I'll show this example. It's very similar to what I did earlier. I did b equal x.b. Now, if you remember, if I would call b this way, it will return 9 because I defined a to be in the global namespace to return 9. But if I want b to actually return the output of the function a that is attached to the x object, what I could do is to call b with call. When I using call, the first argument is this that I want this function to have. So if I call b.call x, then it will return 1. Okay. Now there are pretty interesting things that we can do with it when we do some metaprogramming. We define APIs in JavaScript, but too short for this talk. So I'll give some time for questions, if anyone has. Yes, please.
You showed the example with call. Can you show with apply?
Oh, it's going to be exactly the same way.
So it's like synonymous?
No. The difference is between call and apply. Okay, I'll show this with an example of a function that people should know. Let's see, mass dot. Let's take abs. Abs return the absolute value of a number. No, I want a function that gets two parameters. Min. Okay, let's take minimum. Okay, so minimum. If I call mass.min this way, it will return 9. Okay. Now, if I will use min.call, okay, in the case of math, the value of this I'm almost certain that has no meaning. But the difference between call and apply is that apply gets the parameter as an array. Okay. The first argument of both of them is what this is going to be. The difference is that in call you list the arguments you want to pass. In apply you pass an array, and that array will be passed as the arguments of the function. That's extremely useful when you have functions that get arbitrary amount of number and you want to pass it an array of arbitrary amount of numbers that you don't know how many will be there. Okay, so in that case I can do that and it will be very easy. Okay, last question. Yes?
What is the best practice if I want to create an object to extend another object and using and overriding the function on the parent object? What is the best practice?
What you refer to is called in JavaScript prototypical inheritance. Those of you who are interested in prototypical inheritance, is there a talk immediately after me? Yes.
You can finish this question.
Okay. The answer is too long. I need like 5 to 10 minutes to answer it. But if you're interested, you can catch me after this talk, and I can answer this. I can show how it should be done. I would say if you want, research what object.create is doing. Okay, this function, what it does. Actually, let me show an example. I can take another 2 minutes. Yeah. Okay. Okay. So if I have a variable, let's give it a name, O, a variable O, and that O has A, 1, B, 2, and so on. Okay? So if I call O, I return this. Now, if I want to write an object that will inherit the properties from O, but will be able to change them without interfering with O, I will do the following thing. I will do object.create, and I'll pass O as parameter. Okay? Now you can see that O, all right, sorry, let's call this, this is the inherited, let's call it I. So if I call I, you can see that I is empty. But every object in JavaScript have a hidden property called proto. You can see it here. Okay, every object in JavaScript has it. And it refers to the object in which it inherited from. By the way, that object can inherit from other objects. And here we can see A and B defined. So even though the original object didn't show A and B, if I'll call I.A, it will return 1. Okay? But if I'll do I equal 5, and I'll call, sorry, I destroyed it right now. Let's do it again. Okay, I.A equal 5, then I.A will return 5. And furthermore, if I'll call the original O.A, it will still return 1. Now, the very interesting thing is that the inheritance continue. What I mean by that, if I'll call I.B, it will return 2. Because we didn't define I.B, so it takes it from the object from which it inherited. But if I'll change the original object, O.B, to be 9, and I'll call I.B will return I. And that's extremely powerful. I did some very sophisticated thing with this feature. Just to give an example, say that you have a pool of objects that might change later. You don't know when they might change by one of the APIs that you're using or one of the libraries you're using, and you want to attach a type to each one of them, which is arbitrary to your use case. Okay? You can set the type of each one of these objects by inheriting the original object in a way that if the original object will change, you will have the changed value, but your type will retain. Okay? When we have prototypical inheritance, the object which we inherit from can keep changing, and we can have the up-to-date versions of them. If you want to hear more about this, and I can say what made me a good JavaScript developer, if you want to learn more about JavaScript, follow a guy called Douglas Crockford. This is the guy that I'm citing here. He made the notion of the concept of JSON maybe, I think, 15 years ago. Find his talks, and I promise you, it's amazing, and you will become better JavaScript developers. Thank you very much.